This week's episodes were brought to you by the generous support of Yukofin. Hey you folks, Quill18 here, and welcome to another Unity 3D programming tutorial. In this episode, we are continuing our work on making a board game in Unity. This is going to be a tutorial in two major parts. The first part is very basic Unity stuff. We learn a lot of basic techniques for working with 3D objects, writing some basic scripts, and getting a board game that can be played by two human players. The second part is going to involve more complex topics because we're going to be looking at developing an AI player for this board game, which is then going to lead into a more advanced AI discussion in general for more complex games that will come a little bit later. We are making the Royal Game of possibly the oldest known board game ever to exist. For centuries, for millennia, the rules were sort of lost, but they were relatively recently, as I understand it, deciphered from a hieroglyphic tablet, and it's a really simple game. It's very much, in a very real way, a predecessor to something like backgammon, or even for me, I think of it as something very similar to something like Sorry. Last episode, we set up the basics of the board, we organized our components in a variety of different ways. This episode, we're going to talk about different ways of doing die rolls. Now, in the classic setting for this, you would use, like, tetrahedron dice. It's sort of like pyramids, but with, like, a triangle base instead of a rectangular base. To roll, or if you play Dungeons & Dragons, a d4, basically. Although you don't use the values of 1 through 4 on the dice. Basically, half the faces, or half the points on the tetrahedron are painted or have some sort of symbol to indicate a value of basically 1, and the others aren't, so they have a value of 0. You roll 4 of them, which means you can end up with any number of value from 0 through 4, with 2 being the most common. Now, I'm trying to do as much work as possible within Unity itself, and unfortunately, Unity does not have a tetrahedron type object available. But the thing you have to remember is the way it's set up is basically each one of them just has a 50-50 chance. Each die has a chance of either being 0 or 1 that is equal. It's exactly the same as a coin flip. So we have a few different ways that we can actually organize this. There's no reason we couldn't just use, say, a cube. Paint half the faces white, half of them black, and then, then you're looking to achieve certain values that way. Or you could do a coin flip. Now, the problem is this. There's no reason, for example, that we couldn't, say, use a cube and actually use physics to kind of roll the dice, which always feels really, really cool. Let's not deny that. I'm going to take this cube. I'm just going to go into rotate mode over here. I'm just going to go and offset it a bit just so it looks kind of interesting. This cube, all the cubes by default are set up with a box collider, and the plane has a collider as well. If we go and add a rigid body to this, it will be physics enabled, such that when I go and hit play, let's get our game view back up over here and move our camera in some way so that we actually get an interesting view. Ah, there we go. Excellent. I guess it doesn't matter. We don't actually have to watch from there. If I hit play, this cube, because it's a rigid body, will fall and then settle. If we gave it, a little bit more oomph and a little bit of bounce, then it might roll around a little bit more. And we could have on each side of this cube a painted value. The problem with this, while it's very cool and realistic, that it's not the easiest necessarily to determine for some shapes which side is up. You can do it mathematically with a few different ways. The other thing you can do with this is you can have a series of sort of triggers on each face and then detect which one is touching the surface, and then it's the opposite value that is the cube that you rolled, which works, although then what happens if you've got, like, more than one die? Oh, hold on, we're playing right now. What happens when you have more than one die, which of course we will, and one ends up cocked on the other, right? So let's say we reset the rotation on this guy, and it's lying nicely on the table, and then this one here comes down, like that, and hold on. Let me. This will be easier if I just reset the rotation to start off with. It comes down, and it is resting on the other die like this, or on some part of the board or something. And it's like, well, how do you deal with that? Do you, like, re-roll it? There's, like, all kinds of little question marks around this kind of stuff, especially if you have many dice and they're odd shapes and they can interact in bizarre ways. That starts to become a little bit of a problem for determining that. I will let you know, in on a little secret. A surprising number of games, like a lot of mobile games might show dice rolls. A lot of them are not actually doing true 3D rolls. What they are in fact doing, a lot of them have a made animation for the entire dice roll. Okay, so it like throws in here, flops it over a few times, and it comes to rest on some sort of face. It's a pre-made animation, and they know at the end of the animation, this face is going to be upright. And what they do behind the scenes is they generate a random number from, like for a cube, 1 to 6. And then based on the true random number they generated, they change the texture. They change like the graphics on the cube to make sure that the right number will end up face up at the end of the animation. They might have more than one animation to make it look interesting, but that is actually what a lot of them do. The advantage of it is it avoids a lot of these annoying problems, and it's a heck of a lot faster, especially on mobile games. Determining the physics of like multiple active physical objects that are all knocking about each other and bashing through each other can be kind of demanding. So as a result, this sort of thing doesn't usually happen. You don't usually have physics-enabled dice. What we are going to do, therefore, is we are just like what a lot of things do. We are just going to use a random number generator to determine what value the player has rolled. We will then give the player some sort of visual indicator as to what the dice ended up being. Probably not through the whole pre-programmed animation, because that's actually fairly involved to do, especially if you want it to look right. Really what you would probably do is do an actual physics-enabled animation in something like Blender, and then bake in the final animation, and then it's a whole process. So we're going to do some sort of like visual thing to tell people what the number are. But for now, we're just going to output things to the console. But I do want to have a discussion about different dice techniques that you can look into for your own purposes. Maybe come up with cool solutions for avoiding the cocked die problem. You know, maybe just shake the table up a little bit, or re-roll, or something. There's probably something you can do. If you actually, one of the things you can do is if you just set the die like friction coefficient. Every physics object in Unity has a physics material attached to it. It's part of the collider over here. You can see it's got a physics material. The default physics material has some semi-reasonable settings, but you can make your own physics material. You just create physics material down here, and when you create a physics material, you can just set the friction to 0, and then things will be 100% slippy, and then maybe you won't have too much of a problem. Although you also have to think about, like, where are you throwing the dice? Can things fall off the area? So make a little box for it, that sort of thing. We might look into something like that later on. I wanted to talk about the problem, but what we're going to do at this point is simply randomly generate the number, and then at some point, you know, show the value in a cool, sexy way to the player in some fashion, as opposed to doing the physics-enabled dice rolls, because that would probably be a couple of videos by itself. Anyway, enough of that. Let's get to the point where the player can actually take a turn. We're going to generate a very, very, very simple user interface for the player over here. So let's go and create a UI. So I'm going to shrink down the board over here in my hierarchy. And to create a UI, you do need, say if we will create a game object in UI, you will need, you will need a canvas object and an event system object, but those things get added in automatically the second you add any UI object. So what we want really is we want a button. We want a button the player can click to say, roll. So we go and hit that. If we go and we want to interact with the UI, really what you should do in your scene editor, hit the 2D button, which will just arrange your camera in a certain way. And then if we double click on the button in the hierarchy, there we go. We will be able to see the button very well. Actually got positioned off screen. I'm like, why can't we see it on the game screen? It's actually off screen over here. Let's go. So we've got our canvas, we've got the event system that was automatically in, and we've got our button over here. This symbol over here, if you click on this, allows you to set the anchor where the graphic object, where this button in this case, is going to be sort of parked and locked on the screen, which is very important when you have screens of different sizes, and we'll take a look at that in a second. We're going to say, let's put the roll button in the bottom left corner, just cuz, which is sort of this symbol over here. If you just click that though, nothing will happen to the object. You can see this little like marker over here, that's the anchor. This button is locked to that corner, and if I were to go and resize the screen, the button will try to stay relative to that corner. It's not very helpful right now though, right? And that's because its position is way out of whack. It's got a negative X position. If we go ahead and start moving this, you can see we can eventually bring it onto the screen. And again, it'll be locked relative to that bottom corner over there. The easiest thing to do, rather than mess around with these numbers, click on this symbol again. You can see that Shift also sets the pivot, and Alt also sets the position. Almost always, you will be holding both Alt and Shift, and then click the corner that you want. Boom. That moves the button to that corner, and again, it'll stay locked. Even if we resize this image or this window, the button's going to stay locked to that bottom left corner. Very handy little feature. So we're going to expand this. Now, a button in the Unity UI system is just an image. It's actually two parts. It's an image, which is the background, the visual, and inside it, it's probably got a text object with a word on it. Although it could have an image, a second image inside of it, which would just be an icon, right? And you know, you've got your little hand icon over here, right? So you've got your button graphic, which is the background, and then inside of it you have another graphic, which is your hand image or something of that nature. So this button is just going to be called roll the dice. There you go, with a little bit of drama. Let's go ahead and make it a wee bit taller. So not in the text, but on the button graphic itself, we're going to make it taller. You can do that by adjusting the height over here. You can also, if you're in the rectangle transform tool, which is enabled by default when you're in 2D mode over here, you could just drag it visually to, you know, whatever feels good. You know, let's make it big like that, easy to see. Then let's go back into text over here and let's increase the font size. I'm going to do that by, you can type in something. You can also just click and drag over here, find something appealing. You can also change the font. There's only Arial built in to Unity. If you want more fonts, you actually have to like go into either your Windows or Mac like font folder or download a font from the internet, whatever, and you have to drag the font into Unity over there, into the project, at which point it will be available from this, but we'll leave that off for another thing. So we got a big old button that's called roll the dice, and really the only thing that makes a button as opposed to an image is that it has some sort of script on it that is listening for a click. Now, by default, Unity does provide us with a button script. This button script is totally something you could have just written yourself. It's nothing special. It's nothing internal to Unity. It's just Unity provides us with a very convenient button script. And when you go to UI and add a button, it automatically adds that button script to the button object. Again, not the text. The text is nothing. It's just the text thing. But the button object here, which has an image, right? This image is literally just that background. And then it has a button script. And this button script allows you to tune colors for like when you mouse over and things like that. But it also has this on-click handler over here. This will call a certain function when it gets clicked. And that's what we're going to work on now. We're going to write our very first script, which is responsible for dice rolls. Now, how do we want to make that work? Well, we're going to need, because we're going to work in like pure, Unity objects and components, we're going to need some sort of object, some sort of game object, which has a component which gets told, roll the dice, and then, presumably do something. What I'm thinking is this. We're going to want some sort of visual for the dice. Let's assume that next to this, we'll have like some sort of picture of the dice, and it'll show you what the total is in some way. I don't know what that will be yet, but let's go to the canvas object. We'll right click on that, we'll choose UI, and we're going to create just another image here, okay? And the image, we're going to give it an image source, because right now it's just a white square. We're going to click on the little target. It's got a couple of built-in things. Let's use the UI sprite, which gives you just a nice little rounded corner effect. Looks lovely, doesn't it? Then what I'm going to do is I'm going to, again, click on our little anchor preset. I'm going to hold Alt and Shift, lock it to the bottom left corner, like that. Now, obviously, I don't want it on top of the button. So what I'm going to do is I'm going to drag it sideways, and it will snap quite nicely. There's a little snap right there, and put it next to the roll the dice. And then I'm going to change the height to match the roll the dice. Again, it will snap, or I can manually type in a height here to match, which is going to be okay. And we'll have some sort of area. This will be used for some sort of dice visual over here. But right now it's going to be empty. But I'm going to call this whole thing the dice roller. I suppose it should probably be the die roller, right? Die roller. I mean, there's more than one die, therefore there are going to be 4 dice. But I think I'm going to say dice roller because it's a little bit more clear. People recognize the word dice more than die. So, I don't know. It's going to be fine. Grammar, screw grammar. We're not about that. We're about C# language, not English language here. So this is going to be the thing responsible for the die rolls. So we're going to add a component to this. Okay, it's going to be our very first component. We're going to make a C# script. Now, we can do it. We can create the C# script over here ahead of time, or we can go add component and type in the name of the thing we want to do, like dice roller. It'll note that there's nothing in the search. It gives us a little quick thing for, hey, do you want to just create a new script? We'll be like, yeah, let's create a new script. So we're going to call dice roller. It's going to be C# script. We're going to create an add. So it both creates the C# script in our project over here and adds the component to our dice roller object over here. Seems fine. There's 1,000,001 different ways to do this. We've chosen this way. If we double click on this, it will then open up in MonoDevelop. Or you can certainly be set up for Visual Studio and everything. I still work in MonoDevelop because it is the default in Unity. Makes it a little bit better for tutorials and stuff if it's all the same. Just going to wait for this to load up. Chukka, 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 chukka. Excellent. Get rid of that silly warning because of some of the settings I've got. I'm going to go in and biggen the font so that you guys can see a little bit more clearly over here. And let me make a little bit more screen real estate. So when you create a script in Unity, it automatically pads a few things out. It assumes you want this to be a mono behavior. So dice roller is the name of my class. It is derived from mono behavior. Mono behavior sets up a variety of different functions available inside of this class for you. And it sets up everything you need to make this script something that can be added to a game object. If we were not derived from mono behavior, then this script could not be added as a component to a game object. So we're going to leave that in there. This is normal. This is the normal way you do most things in Unity. It starts us off with two functions. The start function, which will be run once at the start of your program. Well, start gets called before update gets called the first time. But basically, this will get run once. Update will be run every single frame. Now, for a die roller, I don't think that's really necessarily what we need. Certainly what we need for a die roller is a function which is roll the dice. And I think that's literally what we're going to call this function. Now, this could do all kinds of different things. It could return values. It could do all kinds of stuff. I don't think that's going to be the case here. This is going to be something, this is going to be a function that gets run when we push the graphic button, when we push the UI button. It's going to roll the dice, and it's going to store the value. So it's going to have to be a public function, which means it can get called from outside the class, which is going to be required for the button to work. It's not going to return anything. It's going to return void. We don't need to return any value. I mean, we could return the integer value of the result, but that's not really how this is going to be used. Roll the dice. I'm going to write dive every single time. And it doesn't need any parameters, okay? So what is it going to do? So in you roll 4 dice, classically tetrahedrons, basically pyramids, which have half their faces have a value of 1 and half have a value of 0. You could roll actual physics-enabled dice, in which case you would still launch that effect right here. This would be like, you know, you'd actually like pick up all the dice objects, throw them into the thing, and then read their values in some way. We are going to use random number generation instead. All right. So again, half the faces have a value of 1, half of a value of 0. You could be rolling 4-sided dice, which is the classic example with a tetrahedron. You could be rolling 6-sided dice. You could be rolling 100-sided dice, with 50 of them having a value of 1, 50 of them have a value of 2, or 0, sorry. Or you could flip dice, or flip coins, flip 4 coins. Heads are a value of 1, tails are a value of 0. Mathematically, it makes no difference whatsoever. And for a random number generation, we are in fact simply going to random from 0 to 1 is the way we're going to do it. And we're going to do that 4 times. Now, we're going to store all of those values, okay? And we're going to store them in some sort of public way so that something else can read them, okay? We're going to make a public integer array. I suppose it could be a Boolean, because a sort of a true or false thing, but we're going to be doing math on these things, so they may as well be integers, although again, they could be bytes and things, but let's not get into data types. We're making an array. It's actually going to be, I don't think we can do that here, can we? Tell it that it's a size of 4. I don't think so. We'll say dice values. Yeah, it's going to complain. Yeah, we can't actually say that this is a array of size 4 when we define this. You can in some languages and things like that, but not here. So we're going to have an array, which is the individual dice values, and then we're going to have another integer that's not an array, which is going to be the dice total over here. Dive total. Every time! So, by default, this does get set to 0. Which doesn't matter. I mean, we almost want to have like an invalid value over here or something like that, but it doesn't matter. Dice values we are going to have to initialize. So we're going to make this a new array of 4 integers. So it's going to have 4 spots, okay? Dice values an array with 4 areas, and by initializing this way, each one of them are going to start at a 0, which is going to be okay. We're very rarely going to use this directly. This is mostly going to be used for setting our visual. Either in our user interface over here, we'll have graphics for the 4 dice, which will get set to the appropriate version of the graphic based on what's in there, or we will use that to inform some sort of animation, or we will do an actual 3D die rolling or coin flipping effect, and then after the effect is done, we will feed the dice values from there in some way. Here we're just going to randomly generate them. So what we're going to do is this. We're going to say for each, well, no, we'll do a proper loop. So we're going to say 4, and if you hit tab twice, it'll actually auto-complete this little structure for you. Very nice little time saver thing. We're going to go very classic for integer I, so we're going to have an index in our loop called I, which is going to start at 0. It's going to loop a number of times equal to the length of our dice values array, which we know is 4 from setting it up here, but we might want some flexibility. What if we want to make a version with only 3 dice or with 6 dice or something? So what we're going to do is we're just going to read that directly for dice values dot length. So this is the length of the array, which we know is going to be 4. So I equal to 0. It's going to loop as long as I is less than this. So it'll go 0, 1, 2, 3. And then when I goes to 4, it'll be like, nope, that's no good because I'm no longer under this length. And then we'll increment there. So for each one of these, we're going to set dice values at the index I. We're going to set it to a value of random.range. This is how we generate random numbers in Unity. There is a C# built-in random generator, but this is the Unity version. It doesn't really make much of a difference. Now, there are 2 versions of random.range. One that takes floats and one that takes integers. The one that takes floats will return a float, so it'll give us a value of like 1.6333. Okay, we don't need that sort of thing. We want the version that returns integers. Now, the integer version will return a number between the min value and up to but less than the max value. So if we were to put in, say, this, then the random range it would return would be, it would allow us to use the 0, so it would be a value from 0 to 1 less than this. So we get a random number from 0 to 0, which is no good. So we actually want a random number written this way. This will always return integer. It'll only return a 0 or a 1. Note, if you use the float version, which you can actually force by doing this, then this will return a floating point number between 0 and 2 inclusive. I mean, you'll almost never get exactly 2. You'll get, again, 1.63589, some damn thing like that. But it does technically give you the ability to generate a 2. But we're going to do the integer version like this. This will return either a 0 or a 1 in all 4 of these spots. Then what we're going to do is we're going to update the total based on that. Now, of course, we could do that live. There's no reason we couldn't. And I guess we will. So dice total equals 0. We'll generate the random number, and then we're going to add, using this plus equals thing. This plus equals the same thing as saying dice total equals dice total plus this. Like that. But you can make it a little shorter. Now, usually I like to go for legibility, and shorter is not always more legible, but in this case, I think it is very nice to do this. Dice total, we're going to add this dice value over here like that. Boom. So at the end of it, dice total contains our total rolled amount. And this is part of our public like properties, well, or fields, I suppose you should say, our public variables over here, which things outside of Dice Roller can access. At this point, the Dice Roller has done its job. It has rolled the dice, and in theory, something should happen. There's probably going to have to be some other signal at this point, because the next thing is going to be, okay, you've rolled it. What we should do is put a little debug log. Debug.log, rolled. So, we rolled dice. You know what, let's return, if we return dice values like this as a string, I think it'll show us all the individual amounts. And then we can go something like plus, what are we doing? Dice total plus, let's give this a try. This may or may not show me things the way I want. But let's see what this does. If I were to hit play, hopefully we get no errors. If you get errors, check your syntax, make sure you got all your semicolons, your parentheses right. If I hit roll the dice, oh, we haven't actually wired everything up. Ha ha! So we hit the roll the dice button. I mean, we get that nice little that animation as part of the button script that gives us that visual, which is great. But nothing's actually being signaled when we hit this button. What we have to do, the button over here. Okay, this is our button. This is our button. Roll dice. When this gets clicked, so it's got this on click list, we want to hit plus to let it know, okay, something's got to get signaled. This wants to know a game object over here. Again, you can use the little target thing, or you can just drag and drop. We're going to drag and drop the dice roller in there. Then from this menu, we're going to choose what function. The dice roller script will then be told to roll the dice. Now, there's no real reason why we couldn't have the dice roller script on the button or on something else. I'm just choosing this because why not? So now when the button gets clicked, it should call our function that we went ahead and wrote. So I'm going to hit that. Boom, there we go. Rolled. Oh, it doesn't actually give us the list of the items in the array. We'll have to, we may have to change that a little bit. I was hoping it would show us like 1001 kind of thing in there. But we'll have to format the text differently if we want it. But we are getting values. We rolled a 3, a 1, a 2, a 1, a 3, a 2. If we keep going, we'll get mostly 2s. And sometimes, there we go. Oh! No, we're okay. We're okay. I was going to say sometimes we get a 0. Sometimes we should get a 4. Oh, there was a 4. 4s and 0s are going to be very rare. Only 1 every 16 times? Yes. Only 1 out of every 16 rolls will get a 0, and another 1 out of every 16 rolls you'll get a 4. So only 1 in 8 times will you see either a 0 or 4. Most of the times you'll see a 2, and the 1s or 3s are a little bit more likely, just because of the statistics. But we seem to be getting all the values that we would expect to be getting out of the die roll. So excellent, we've done that. I know this is a little bit of a slower paced tutorial, but it's been a while since we've been a little simpler. The hex tutorial was a little bit more complicated. But again, when we get to the AI bits, things are going to get pretty hairy pretty quick. Hope you're still finding this tutorial useful and good for a beginner. Thanks for watching, folks. I'll see you guys next time. Thank you to all the October patrons who make these videos possible, including these Mike Check supporters: Yoko Finn, Eric Sumner, Adam Keenan, Danny Welch, Tiburon, Mighty Mix, Pavel Zdanov, Michael McClintock, Aaron Tyson, Rorskal, Gurko Dries, TNSEE, Jasper Bisgard, Julien Gelafond, Marius Field-Vold, Speedy Savant, Steven Steger, Thomas Oberson, Jason Yanity, Stephen Bonnerman, Easter Egg Productions, and Neil Blakely Milner, as well as everyone who likes, favorites, and subscribes to these videos. Thank you very, very much.